Hey, wonderful people, and welcome back once again. Today we have this interesting question right here. X to the power x plus 1 is equal to 3. And we want to figure out the value of x that will satisfy this equation. But before we start, I believe you know the deal. Pause the video, give it a try first, and if you are done, you can come back to the video. Without further ado, let's get right into it. In fact, a good way to see this question right here is this. We have x to the power x, then to the power x again, plus 1. Now, this plus 1 simply means that this x to the power x is multiplying another x. So I can say that this times x again, and this is equal to 3. Cool. Now, we can also see this from different perspective. Let's say we have a to the power m times n. We can rewrite this as a to the power n times m. And actually, we can also put this in parentheses and it doesn't change anything. If we compare this right here to what we have here, we can see that m is x to the power x, then n is also this x right here. And of course, we can interchange their positions in this form, right? So we are going to have x to the power x, where this x is this x right here. Then I'll put this in parentheses just like what we have here. And m is now x to the power x. So we are going to have x to the power x. And this is equal to 3. Cool. Now this time, let's drop this power down and then proceed right from there. And to drop this is either we use log or natural log. Either of them will work, but I'm going to go for natural log. So I'll just introduce natural log on each side of the equation. And of course, all the powers right here will move to the front. So we are going to have x to the power x ln of x to the power x. And this is equal to ln of 3. Great. Now check this. I'm going to write this first because multiplication is commutative, right? So we will have ln of x to the power x, then times x to the power x. But remember, we can rewrite this in different form. We can write this as e to the power ln of x to the power x, because this e and this ln will undo each other, and we will get x to the power x back. So honestly, we have done nothing to this term right here. Great. And of course, the right-hand side is still ln of 3. And this time, you can drop all the powers down like this, right? And if you do that, we are going to have x ln of x times e to the power x ln of x. And this is equal to ln of 3. Now let's consider the left-hand side of the equation. The coefficient right here is the same as the power right here. Then we have e here. Remember, if this happens, we can actually apply Lambert W function. Check this. Let's say we have any input, nice emoji like this, times e to the power the same nice emoji. Remember, if we take Lambert W function on this input right here, we will still be getting our emoji back. This is to say that if you have any input like t e to the power t, if we take Lambert W function on this, we will still be getting our t back. And remember, always the number right here is supposed to be e. And of course, we have e here, meaning that we can actually apply Lambert W function on each side of the equation. So let's go ahead and then do that quickly. So on the left-hand side, we are going to have w of x ln of x e to the power x ln of x. And this is equal to w of ln of 3. Great. And remember, emoji e to the power emoji, we will get emoji back. So on the left-hand side, we are going to have x ln of x, and this is equal to w of ln of 3. Now, it seems there's a problem again because we have x ln of x instead of x alone on the left-hand side. So we have to go through another process. See this? I'm going to write ln of x first, just like we did before. Ln of x, then this x right here, I'm going to see it as e to the power ln of x, and this is equal to w of ln of 3. Great. Now, just like we know before, what is here is the same as what is here. Therefore, we can also go ahead and then introduce Lambert W function on this side of the equation. Each side of the equation, right? So, like this. And of course, on the left-hand side, we are going to have ln of x is equal to w of Lambert W function of ln of 3, like this. And of course, to get x alone, we have to introduce e on each side of the equation so that this e and this ln won't do each other. Then we'll be left with just x on the left-hand side. Then on the right, we'll have e to the power w of ln of 3, like this, and that is basically the value of x. But of course, we can rewrite this in different form. In fact, we are going to have x is equal to, this will be Lambert W function of ln of 3, or divided by Lambert W function of Lambert W function of ln of 3. And that is basically it. So if you get to this point, you can choose not to proceed because you get the exact same thing. In fact, we cannot compute this on a normal calculator unless product log calculators, just like Wolfram Alpha. So if you use Wolfram Alpha for this, the answer is going to be approximately, let me get rid of this. In fact, the final answer to the problem is x approximately equal to 1.49546. And that is pretty much it. If you go ahead and then replace all the x's with this approximated value right here, you'll be getting approximately 3. So guys, that is pretty much it. I hope you found the video useful. Don't forget to give me a thumbs up, subscribe to my channel for more, and see you again on the next video. Have a nice day. Take care. Don't forget to subscribe. Yeah. Bye-bye.